Which planet has 14 moons named after sea nymphs, circles the sun every 165 years, is pummeled by supersonic winds, and has only been photographed from close range by a spacecraft once? Neptune. They all sound so insane. Did you know all these? But Neptune, the solar system's third largest planet after Jupiter and Saturn, is rarely seen in our solar system's family photo albums. When scientists first saw the first two photos of Neptune, they were astounded. What did they witness though? What impact will it have on you? So stay tuned as we bring you NASA's unexpected discovery on Neptune. Hello everyone, welcome to Space Discoveries. Subscribe to the channel for every single detail about the discoveries in the vastness of space. Also, do not forget to hit that bell icon for new updates. Having said that, let's get started. The Voyager 2 spacecraft traveled close enough to Neptune roughly 33 years ago, providing humanity its first and only close encounter with the planet. Thanks to the Voyager 2 spacecraft and the Hubble Space Telescope for this, Neptune is the 8th planet from the Sun and the furthest away. It's a beautiful blue sphere named after Neptune, the Roman god of the sea. Pluto used to hold this distinction, but the International Astronomical Union demoted Pluto to a dwarf planet. Neptune circles the Sun once every 165 years, despite its distance of almost 3 billion miles. As a result, it hasn't completed a full round around the Sun since its discovery. Neptune, also known as a gas giant, is one of 4 planets outside the asteroid belt that fit into this category, along with Jupiter, Saturn, and Uranus. These planets have a diameter of 4 to 12 times that of Earth, no solid surfaces, and massive atmospheres containing considerable amounts of hydrogen and helium, as well as traces of other gases. With an equatorial diameter of 30,775 miles, Neptune is the smallest gas giant in our solar system, not to mention the fact that it has a volume of nearly 60 Earths. Neptune is the only big planet visible through telescope. It has an apparent brightness of 7.8 and is 1/5 as luminous as the weakest stars visible to the naked eye. As a result, it's fair to conclude that Neptune was never seen until telescopes were invented. In recent years, telescopic observations of Neptune from Earth have revealed tantalizing clues about dynamic cloud patterns on the distant planet, allowing scientists to estimate the speed of the planet's rotational winds. In this environment, Voyager's scientists prepared for the first and likely only close contact with them that many of us would ever have. In the summer of 1989, NASA's Voyager 2 became the first spacecraft to glimpse its final planetary destination since leaving Earth 12 years ago. Voyager 2 has come the closest to any planet, traveling about 3,000 miles over Neptune's the North Pole. Voyager 2 flew by Neptune's biggest moon, Triton, at a distance of around 25,000 miles. As a consequence of what they discovered 5 hours later, academics and scientists alike were forced to reconsider their knowledge of the solar system's other major planet. The most obvious characteristic in Voyager photographs is the planet's blue hue, which is produced by the amount of methane in the atmosphere. Methane is more easily absorbed by the longer wavelengths of sunlight. The only colors remaining to be reflected are those on the blue end of the spectrum. Despite receiving about 1/3 of the amount of sunshine that Jupiter does, Neptune is a vibrant planet. Hurricane-like storms may be observed on Jupiter's surface as many large black patches. The greatest of these craters is huge enough to hold the whole planet. The stone's dimensions were believed to be 8,000 miles by 4,100 miles, similar to Jupiter's red spot. It was thought to be a vortex at first. The Voyager 2 spacecraft photographed Neptune's huge anticyclonic storm in 1989, the Great Dark Spot, as dubbed by the discoverers. Appears to be an anticyclone similar to Jupiter's Great Red Spot. Neptune's Great Dark Spots are almost the same size as Jupiter's Great Red Spot and are located at the same latitude. When compared to Jupiter's Great Dark Spot, Neptune's Great Dark Spot is substantially more variable in size and shape. The brilliant, crisp, cirrus clouds that cover the Great Dark Spot's southern and northern borders might be similar to the lenticular clouds that form atop Earth's mountains. A dazzling, irregularly shaped, eastward moving cloud orbiting Neptune at about 43 degrees south, traveling faster than the Great Dark Spots, and surveying the planet in about 16 hours, this scooter might represent a cloud plume as it ascends through cloud decks. A second area, known as D2, has been recognized by Voyager's scientists 55 degrees south of the Great Dark Spots. Voyager also detected the heat emitted by Neptune's atmosphere. The atmosphere is hotter at the equator, colder in the middle latitudes, and warm again near the South Pole above the clouds. It's also worth noting that Neptune's magnetic field has the same polarity as Jupiter's and Saturn, but is the polar opposite of Earth's. Neptune's magnetic field also gives further information on the planet's structure and behavior. Auroras, which are similar to our northern and southern lights, were detected in Neptune's atmosphere by the Voyager spacecraft. Auroras are caused by electromagnetic radiation from the Earth's magnetic field line. The aurora may erupt across broad areas of Neptune rather than only at the planet's magnetic poles, due to the planet's tangled magnetic field. The aurora on Neptune is expected to have a power output of roughly 50 million watts, compared to 100 billion watts on Earth. Triton's size sets it distinct from the other frozen satellites, and its orbit around Neptune takes 5.875 days at an average distance of 205,000 miles above the planet's cloud top, as discovered by Voyager. Triton is around 3/4 the size of Earth's moon, and orbits in a tilted circular retrograde orbit. Active geyser-like eruptions, spewing forth nitrogen gas and black dust particles several kilometers into space, are seen in Voyager 2 photos, demonstrating Triton's complex geological past. Triton has a diameter of 2.066 grams per cubic centimeter and is around 1,680 miles wide. This shows that the Triton's interior is more rock-rich than the ice satellites of Saturn and Uranus. Triton's high density and retrograde orbits both indicate that it was captured rather than produced in the neighborhood of Neptune. If this is the case, tidal heating might have warmed the satellite right in its initial eccentric orbit, and the satellite could have stayed liquid for up to 1 billion years after being grabbed by Neptune. Triton's past is unknown, but ice volcanism is undoubtedly a part of it. And at minus 235 degrees Celsius, it is the coldest planet in the solar system. To grasp what is going on Triton, one must first ask, what does it mean to be cold? What is the meaning of the word softness? What does it mean to be young? On Earth, water ice with a 0 degrees Celsius melting point deforms more easily and faster than rock. However, in the very frigid temperatures found on Triton, which is more than 4.5 billion kilometers from the sun, it becomes almost as hard as a rock. Nitrogen and methane ice are too fragile to support much of their weight. The majority of Triton's surface geologic formations are most likely comprised of water ice. Nitrogen and methane form a thin veneer on Triton that changes from ice to gas at temperatures less than 100 degrees, above absolute zero. The bulk of Triton's geologically recent eruptions at very low cryogenic temperatures are caused by nitrogen and methane. Many geyser-like volcanic vents, which appear to be spouting nitrogen gas covered with incredibly minute black particles, were photographed by Voyager and revealed evidence of such eruptions. The particles must first be raised to heights of 1 to 5 miles in the air before being blown downwind to reach Triton's surface. For a long time, astronomers speculated about the possibility of incomplete rings or ring arcs around Neptune. Shepherding satellites, most agreed, would herd particles between them, preventing them from escaping into space or falling into the planet's atmosphere. This idea explains certain unusual phenomena in the rings of Jupiter, Saturn, and Uranus. As Voyager 2 reached closer, its cameras caught a ringed arc-like pattern. A closer look at the pictures in the rings reveals that they cover around the globe, thanks to improved computer processing and resolution. Because the rings are so scattered and the material emblem is so fine, Earth-bound astronomers were unable to detect the entire ring system. One Earth-based ring arc observation was now confirmed to be produced by the transit of a minor spacecraft through the ring region. Researchers were able to calculate the number of rings and a provisional name late in their encounter. According to Voyager's discoveries, Neptune's surface is vastly different from that of the Earth, because the planet's interior is filled with dense, pressurized gases. The planet's surface is covered in thick clouds. The majority of the interior is made up of rock and ice. It's impossible to predict what the future holds for satellites. So, what do you think about this? Did Neptune and Triton amaze you? Tell us in the comment section below. Also, you can add any trivia if you already know about Neptune. Having said that, that's it for now. Thank you for watching the video. If you liked the video, then don't forget to press that thumbs up button and also that hot red subscribe button as well. We'll see you in the next video. Until then, peace.